I'm Jesper. I'm an engineer, and I'm going to present you my talk. It's all the family thing seems to be very, very popular. I've been working sort of isolated, so bear over with me if I'm presenting stuff that you have obvious solutions for. But anyway, I'm going to present this art project called the Doghouse, which is oh, that's me first. Project I've done, engineer. I'm building usually museum installations. I have a background in computer games. I've been doing that kind of stuff for 10 years. And the past couple of years, I've been working on museum installations. Last year, or late 2013, we got involved in this project, which is called the Doghouse, which is a first-person film seen from 5 perspectives of a family dinner, where the son of the family is bringing his girlfriend home for the first time. And it's a social setting seen from 5 perspectives, so it's been recorded 5 times where each person have been given a VR rig on, or been carrying a VR rig. We're going to see a short piece of it here.
Vi har altid været meget glade for mad her i familien. At det er meget skægt.
You don't get this. It's Danish, so I'll excuse it. But the point being that you see it from the first-person perspective. The video footage we saw was a cutout of the real stereo thing you were looking at. You experience it like this as an art installation, where you enter a room with the same table as is being filmed from the 5 POVs, and you experience the same story at the same time. So we have a network set up where we play back the same thing. There's no interaction between the players. The setup we're using looked like this. It might seem quite familiar if you saw the last talk, like GoPros on the head. That seems to be all the rage at the moment. These are the actors, one of the technical guys in the middle here trying it out. So this is how it was actually recorded. The rig itself is based on 2 GoPro Hero 3, which have been modified to be using 85 degrees fisheye lenses, which was bought off USA or something like that. I really don't know where they came from. We have an HDMI transmitter in the backpack and a live HDMI out, which we're transmitting back to the director while we're recording. Recordings gives footage that looks like this. This is after it's been stitched, so as we saw in the previous talk, the problems that you get 2 files, you need to sync them, and you need to align them in a way it makes sense. Because we had the HDMI transmitter, it was possible for us to transmit the signal directly back into the second room, where our director could sit and by radio instruct the characters to give them cues like this is the time to do this and that, so the 5 stories don't get too much out of sync. So we were involved in the problem as technical people. I've never done film or anything like that before, but we were involved, the company I'm working for, Kanako, to try to solve this problem that we have this footage, we are recording it like this with blind faith that we're able to unwarp it again and put it into Unity. So if you don't know why you're here, this is the problem we're solving. The idea of our rig is relatively simple. It's basically just placing 2 cameras as close to the eyes as possible, give them as wide field of view as possible. So we're basically recording the world from 2 points in front of your head. And we believe that that's a way to pick up the first-person perspective, and we think that works. Again, video footage looks like this. It gives you a stereo feel. So when you see it, you actually have the depth through it. And we don't really deal with depth because we just record from these points, so we don't really care about how it looks. Because we're doing these very wide field of view recordings, and since the Oculus and the VR rigs are relatively narrow field of view, the idea was that we're recording so much and we have this like narrow field of view that we could scrub around into it. So the solution we built was made in such a way that we're actually recording like half a sphere of video in front of you, and we allow you to look around inside this sphere. So if you just sit on your bottom and look straight ahead, you'll just be staring along the direction of the actor acting, but if he's walking down a hallway past the clock, you can actually turn your head and see what time it is. as mentioned earlier, we are doing this by reprojecting the images we're recording. We're using a texture and we're projecting it into a geometry inside Unity. The point being here is that if you look at stuff from the same place it's been recorded from, it doesn't really matter what surface you're projecting on. And we are projecting on boxes. Boxes are nice. I don't like spheres. They're too complicated. So the problem we are solving inside Unity is that we have the Oculus rig, basically just the prefab we drag in. We have two cameras. I do a layer for left and a layer for right, and I do a box around each of them. I need to be able to separate the two surfaces because I need to treat them differently. They basically need to pick up their video from different parts of the recorded format that we have there. So when I need to fill out a pixel, I do a lookup inside the video, and that's basically how it works. Loads of problems. The stereo in the field, or the stereo in the system we're doing, it works really nice when you just look straight ahead. If you look up and down, everything is nice. But as soon as you look to the side, you break your interocular distance. You can imagine if I've been recording you like this, the recording rig looks this way, and if I, while playing back, looks to the side, the only image I have is from cameras placed behind each other. And that's a problem, because it just breaks down there. We didn't solve that at the time we did the Doghouse, but since then we have solved it by doing a fallback to a mono view, which basically we serve the same, we serve the left eye for both eyes. So the world just turns flat, but you keep the perception of where you are, and it's perfectly okay to do the storytelling in those areas as well. Doing head tilt like this is also a problem, and I haven't got a solution for that yet. We're probably going to do a fallback to mono view as well. The trick for actually doing this, when you drop in your Unity or the DK2 prefab, your two cameras that move around while you have your VR headset. The first iterations we did, we just placed boxes around the head. And put the textures on there. But since we're moving around, I need to adjust things all the time, and that gives you problems with update and late update. At what time does things happen? And there's some black box magic inside these development kits. So the solution we came up with was basically just blow the boxes up to huge proportions so we don't care about the character moving around a little bit with his head. And that just seemed to solve the problem. And then, as said before, we have a left and a right layer for each box, and we call them out in the camera settings for each camera. That's basically what we're doing. To show, this is meant to give some like direct hands-on experience on how you can do this. So the way we're filling out pixels inside these boxes is that we're using the color component of the vertex shader, or we're using the vertex shader to pass in the local coordinate of each vertex inside the box, and the graphics cards are built in such a way that they interpolate them nicely. So I have like a directional vector for when I would need to fill out my fragment. So I can pick up my direction, and it's picked up here, and then I basically take the direction straight ahead, and the pixel I need to fill out, measure that angle, and that defines a sort of lookup I need to do inside my video texture. The dead center of the round images should be straight ahead, and the ones on the edge should be like 89 degrees or whatever the fisheye lens is delivering. Last trick is that each box I'm coloring red and blue, so I can look at the color to determine if I'm filling out the red or the blue, but the left and right side of the camera. For the Doghouse, I sat in the middle of the night just trying to do some stuff that would work, and I did basically just trying all sorts of functions where I could adjust stuff to see if I could hit like the curvature of the lens, because we didn't have the curvature of the lens, like knowing from when light enters from some direction out here, it enters the lens and ends up somewhere inside my round picture. I don't know how that looks like. But we came up with a guess. I think it was a function like this, and it sort of worked. At least it worked nicely in the middle, which is also the area where the stereo works nice. It sort of breaks down when we look to the side, but the stereo also breaks down, so we didn't care at the moment, at that point. To do the playback, we use a video plugin called AVPRO QUICKTIME Playback. I think it's been the best video solution we've had in all the trials we've been doing. We have been doing some trials with using external programs to render video and pass them in as a texture using stuff like Spout and Siphon, I think they're called. But even though the video plugins are very good, the frame rate is still low. We should be above 60 frames per second, but at the moment I think we are around 20. I've been given some advice here that I'm bringing back home, like which codecs we can change to and those things. But we really need to address this. But it doesn't stop with just the video codecs, because we also need better cameras. At the moment, the cameras we've been using for the GoPros we've been using, we have had a frame rate around 30 or something like that. Newer generations has come up, so we can use a faster frame rate. But I would reach 60 frames before I'm really confident that this would be a better product. Let's see if this works. When we did the Doghouse, programming at night, guessing functions, basically just hammering code together to make this work, we ended up with a product where we needed to adjust this, like the curvature of the lens. We found that was sort of okay. But we had another problem that suddenly came along, and that was that just before the first takes were supposed to happen, we figured out there was a problem with one lens, so we need to replace that lens. So we got another lens, and that lens had another filter, which meant different colors, so that was just a can of worms. Adding more problems was that the rig was built in such a way that when we did recordings and needed to take out the footage, we needed to disassemble the rig. So I basically stood with 5 films where the cameras were pointed in slightly different directions, and that was really a pain to work with. So the player we actually did was so configurable that you could adjust all the video. Really, really a pain to work with. But when everything settles after we've been doing this, and it turns out to be a success, people like it, people have arms over their heads like, whoa, this is so amazing. You get the Minister of Culture to hand over prizes to the team, and you actually see posters on the street of this thing you're doing. That was just immensely cool, so we forget all the problems. If you're going to do stuff like this, the advice, I've touched upon some of them, make really, really sure your camera mounts are mounted the same time every time. Do a system so you can unload the video without touching the cameras. It's just going to be hell. Just get some basic knowledge around these filters that the lenses use, because the lenses are actually very complicated. It's like stacks of glass and all kind of stuff. I really have no clue how they're working, but they're complicated, and they're different, all of them. The right curvature is also, as mentioned, very important. Shop in sets, so you, at least if you don't know what you're getting, get something that's the same for both sides of your recordings. Then you're going to have a better time. And another problem that I'm going to pass on is when you're recording stuff like this large field of view, just because the cameras are shadowing for each other. If I did a recording here, the light from the window would be dominating the right side view. So it's important that you have an evenly lit scene, so you have some video that's comparable, so the left and right eye actually fit. If you don't have that, you're going to have like artifacts on one side that you can only pick up on one eye, and then you get dizzy. Like this. So after the Doghouse in 2014, things sort of ended technically from that project, and I started thinking about what could we do from here. I met up with my good friend Diana, who's running Knapnock Games, and we talked about could we bring this further in some way. So we discussed back and forth, and we came up with a solution saying, let's try doing a streaming solution for this, so we could do something real time. Without really knowing what to use it for specifically, we just started work on it. And this is one of the prototypes from there. The small note here is for me to remember saying that it's really hell building these cameras, because only recently there has become 360 cameras on the market, so you can actually buy something. All these prototypes, I have to change them with a hacksaw to be able to fit in those custom lenses, and everything is glued together. It's really just a workflow that's not good to work in. But while we were doing this, I was looking at different cameras, and I fell over the Mobius Action Cam. It's a runner-up for the GoPro. It's a really nice camera. It's cheap. It's around $100. You can buy them off eBay. But the most important thing is that you get a structure that you can extend with an extension cable. So the idea that came to mind obviously was that we could have a much smaller camera because it's only this thing we need to strap in front of the character, and we could extend the cord like this. And it has this standard M12 12 millimeter lens mount. So let's take our lenses, put them in there, and that brought us to this stage where we were building prototypes of a much more lightweight rig. I actually have one of them with me. Never leave stage while speaking. This is the rig, and it's relatively lightweight. It's easy to operate. I think if we are lucky, I should be able to make a small footage or something like that. But basically, we can take this rig and I have an external power source to run it. I'm not using the power source to run them for energy reasons, but because I'm powering them from an external source, I get a synced recording from them. So they're set up to start recording as soon as they get power. We're probably going to look at this. I'm going to set up outside afterwards, and you can sort of see the workflow we're using. But anyways, this is the prototype. So suddenly we had something that was like usable, like directly. It's easy to use, and we just set it up, and it's not overly expensive. So Diana and I talked. What could we do when we talked to our network? And suddenly we ran into Natasha. Natasha has been doing erotic content for the past 15 years. She's really, really well respected. She's been doing stuff for Cirque du Soleil. She's been featured in the Rolling Stones magazine, and she has a huge audience for the stuff she's doing. So we decided to team up and try to see where we could take this. So we had a technical solution, we had a creative solution, and now we're just trying to see where can this take us. So we created this Permission VR collaboration company, where the goal is that we'll try to take this technology and actually make it into a product that we can hit the market with. The team at the moment, that's me. I'm in charge of stuff when it's not working. Natasha is in charge of all the creative stuff, and she's also our CEO. And Diana is also located with me in Copenhagen, where we're working with. She'll be helping with the interactive parts of doing this production, because this is new areas, and we know where we're going, but there's a lot of problems that we need to solve on the way. Oops. So this is a picture from the first shoot where the actual prototype was actually used for this. It was basically just a pretty photo shoot, but I'm really proud to see my prototype from the garage actually being used in something real, and that's a highlight for me personally. So suddenly we came from just having prototypes, having art installations, and we now have a mission where we actually want to do stuff and bring stuff to market for real. So at that point we needed to improve ourselves. So where can we improve? So from here on, I'm going to focus a bit on the problems, challenges, and the future I see from there. This is a part of my camera lens zoo. We have all kinds of examples from different shoots, different takes, different places. The main problem that we're dealing with is that all lenses are different. The key problem for us to solve is that we need to be able to place the pictures as accurately as possible to give people the 3D feel that needs to happen. If you just stray away a couple of degrees, people are going to notice, and then you're going to get dizzy. So as said before, the lenses are all different. This is an example taken from the courtyard yesterday, and you can see the lens here. It's a complicated thing, and because I changed it with a hacksaw and I've been touching it with my greasy fingers, things are a bit crooked. You can see here that the image is not directly centered, and the curvature of the lens, they also differ. So that's the kind of problems that we need to improve on. So I thought, what can we do? And I looked into what are people usually doing? A lot of people are using OpenCV, and you can have these checkerboards and move them around. And I'm sick of it because it's not working for me. I don't know how to make it work. So So I needed to do something else, and I remembered one of my old teachers who said, keep it as simple as possible. So I brought along just a simple tool where you can measure angles, basically just like you can point it at stuff, point a thing like this at stuff, and you can read off what angle things are coming from. So we built a simple rig like this up here. Luckily, it's fisheye lenses, so they look all the way to the side. So we just stick them to the side, put them in a courtyard, choose a place far away, so we don't need to take care of stuff like rotating the camera not around the exact center of the focal point. So I'm basically just setting this one up and picking a point off in the distance, reading off the degrees, and then I'm tilting the camera while following how far this fixed point is moving through the lens. And that gives me curves like this. The leftmost is the one we guessed in the beginning. It was sort of okay, but looking at different lenses, I can clearly see a difference in how they behave. So, and the data looks relatively noise-free. So I'm quite confident that this is at least better than the stuff we've been doing before. To be able to be productive working with other people, Natasha is working from San Francisco. We are located in Copenhagen, Diana and I. We need a system where I don't need to be involved in all the shoots. We need something that really scales. So we were forced to build a production pipeline that really works, and I'm just going to briefly talk about it. All the camera prototypes and calibrations, that's the stuff I'm doing. Then we're shipping the cameras off to Natasha, who's planning shoots and doing all that kind of things. And she's doing the recordings. Every recording pans out into a movie. We call them left and right movie. Good naming. And then we have a script that basically takes them, synchronizes them in time. We do that by picking out the audio track and trying to offset them until they fit as well as possible. That's completely automated. And then we end up with a pile of clips that Natasha can take into Final Cut and do completely regular video editing and build up the story that you need. We are also adding some interactive parts, but I'm going to get into that briefly a bit later. At the end, we're going to end up with a file, so we build a system, or we're going to end up with a movie, and that movie, you dump it somewhere, and we're going to wrap it up so you get an executable, so we have a pipeline that's automated as much as possible at the moment. A brief look into the pipeline. I'm using Python to stick everything together. I love Python, it's just a nice thing to work with. A special mention goes to the PRAT project, which is this speech synthesis software that allows us to find the synchronization between the videos. And we use FFmpeg to build a pipe or build a filter that will deal with the video, like take the left video frame, know that the left frame is crooked in such a way that we need to offset it. So with a setup like this, we have a pipeline where we can end up with a result like this, like minutes after we've done the recording. And looks like this or this, and these are all different cameras. So we are doing content, and we are doing something in the new VR world, and we need to have some sort of interactivity. So alongside all this stuff, we've also built a script engine, and we've separated the script engine from us in such a way that we build a language where you can describe different scenes. So we allow Natasha to build up stories like there's an introduction, and if you look at a certain thing, or if you nod or that kind of stuff, you will scrub around the movie. And in that way, we build a system that enables you to build stories like in these choose your own adventure style. This is sort of where we at the moment. So I'm going to talk a bit about the things that we think are coming next and the things that we are going to focus on. First of all, add more cameras. I think it's overly cool, and it's the obvious thing to do. It's going to break a bit with the idea of picking up light from directly over the eyes, like here. But when we do the playback, we're going to have huge areas behind us that has no imagery. So we can easily add more image there. And when we look to the side, the current solution, which we fall back to a mono view, and that can easily be extended. So adding more cameras, we're going to work with that. The Doghouse installation, in the back of the helmet, we installed a mobile phone to pick up the head movement. The idea would be that we would be able to, by having that data, we would know about stuff moving in the scene. So that's one of the things that we're going to pick up on again. We're working intensively on finding a better representation of the video. At the moment, it's this 2x1 video frame with left and right side by side. But that video format, it contains the complexities of the lenses, and it's a really bad thing in a system that's supposed to be scalable, is having the player know too much about like your production pipeline. So we're working on how to standardize that and do the cut between the content and the player in a sane way. And we're looking at cube maps and these heliocentric mappings. We haven't decided finally yet, but I think we're getting there. Another thing that we should do, we've been very successful in measuring the lenses that we have by just having this measuring thing. But I think we should measure the different light bandwidth. If you look at the Oculus, you can see that they treat red light and blue, red, green, and blue light differently, and we should do the same. So that's an obvious addition to make the product better. I have a bit of a call out to Unity, because doing stuff like this has forced us to work outside Unity for most of the problems we've been solving. We're using FFmpeg to deal with video editing, compositing, how it should look, all the post-process after recording. But we really need some better tools to deal with video inside Unity. At the moment, video is too flat to work with, so we've been forced outside. I would really like to see something OpenCV-like inside Unity that would allow me to like take a piece of the screen and analyze stuff. Imagine a plane is flying by an actor. I would be able to using OpenCV-like features to track where the plane is in the frame and use that for interaction. So I'd like to see that, and of course it should work in these 3D environments. Most OpenCV I've been looking at have been intended for rectangular images, and all that stuff breaks down when we turn into cube maps. A special mention goes to the Fryer project, which is like this opportunity to write shader-like warps of your movie. So you could take a movie like the two we have here, and I could write a plugin that would map it out to a heliocentric mapping or something like that. So all this stuff, these are great products. I'd like to see them easier to work with inside Unity. So, future, we need better cameras, higher frame rate, higher resolution, and we need to increase the FOV as much as possible. We are currently looking at a zoo of cameras. We haven't decided what's our end camera at the moment. It's none of these. We need something that's 60 frames per second, but we are getting there. Every prototype is improving. This is a test shoot of the Kodak SP360. I'm really impressed with this camera. These are placed 6.5 centimeters side by side, and you can clearly see the housing of your neighboring camera. I think the pickup point is around there on these cameras. So these cameras, they get better and better, and they improve the experience we're doing. When we did the Doghouse, it was just a matter of smacking on left and right video in front of each other. We basically just aligned them so they fitted, and things looked good in the beginning. We are improving and getting better at every generation of our prototypes, but I think the holy grail for us in doing this is when we reach a precision, so we're able to mix in 3D objects, so we can have virtual objects to support the interactive parts of our storytelling. So this is where we are at the moment. I'm going to set up outside. Currently, we are working on closing the first investment round, so that will enable us to go to market with this product. If you're interested in business, or if you're interested in technology, meet me outside. I'll take this recording, try to put it into the Oculus, so you get a feel of how the pipeline works. And I also have a demo that Natasha has been made that you can see outside. If there's any questions, I don't know how much time do we have? 5 minutes? Yeah?
Okay, so I'm interested in how have you handled the motion sickness side of, because like Oculus normally is, people are very sensitive to motion sickness with Oculus even when they're controlling the motion themselves. But now that the motion is purely in the hands or in the head movement of the actors, wouldn't that like be a really bad cause of nausea?
I think for practical reasons, the way I treat that problem is speaking to Natasha doing the content, and we agree on we should move the head as little as possible. so we try to do as steady takes as possible, and that's saying that the actor controls your head movement. The system has the freedom so you can look around yourself, so you have some level of freedom. I think one of the, if I had the OpenCV tools readily available, I would be looking into image stabilization in the video to be able to do like keep a horizon steady or something like that. But this is stuff we're researching at the moment. We haven't come up with any certain conclusions. So keep your head steady, and that's good for the experience.
No further questions, I guess.
Once again?
No further questions, I guess.
No further questions.
No.
Thanks for listening. I hope you had some insight in how you can do this stuff, and you get some insight in what we are doing. Come try it out. We're quite proud of our product at the moment. We are getting better, but we have some concrete to show you. Thank you.